Today in the workshop I'm going to be talking about tailstock die holders, and specifically this tailstock die holder from Hemingway Kits. It's got a rather interesting design and some novel features, so I'm going to explain to you later in the video how it works. I'll show you how to make it, and I'll also explain why, in my opinion, this is the best tailstock die holder available for the home shop machinist. There is, of course, more than one way to cut threads in the lathe. Single point threading is a good example, and I'll talk more about that later in this video actually. But for everyday standard sized threads of a reasonably small diameter, by far the quickest and easiest method for doing this, in my opinion, is to use a die. Now, if you're not too familiar with threading in the lathe, you might be wondering why not just use a small handheld die holder like this one. Well, the answer to that is the fact that it's difficult to get the thread started, as you might be able to see here, even though I'm just using brass. And it's also very difficult to keep that thread straight once it does start. One trick you can use is to bring in the tailstock and extend the barrel to square up the die holder on the work there. This does give you a bit of a better chance to get the thread started, and it does help in keeping the thread straight. This is fine for shorter threads normally, but for longer threads there's no guarantee that you're going to end up with a straight thread, as you can see here. So this is where the tailstock die holder comes in. Now, as the name suggests, it mounts in the tailstock of the lathe itself, which means that it's directly on centre line with our part, and the die is presented completely squarely with the work, meaning that we're going to end up with a much straighter thread that's also concentric with the part. Now, this is a big improvement over the handheld style of die holder, obviously. This model in particular has a torsion bar fitted, which gives you extra leverage when cutting larger threads, which is great. Some models don't even have that, they just have a knurled surface. But it's by no means perfect. I wouldn't want to use this under power, for instance, because that torsion bar interferes with the carriage, and if you were to run that thread all the way up to the end under power, it's going to whip round as soon as you hit that shoulder and cause you a big problem. And this is why I love this Hemingway Kits die holder so much. It's got the torsion bar to give you the extra leverage and to help get the thread started, but it's also got a built-in clutch mechanism, which is really clever. So when you reach the end of that thread and it hits the shoulder, it doesn't just whip round, the clutch disengages and the whole unit just free spins. And then you simply stop the lathe, put it in reverse, pull the actuator again, and it disengages itself from the thread. I'll explain more about the clutch mechanism later on and how that works, but firstly let's get on and make the die holder. Included in the kit you get all the free cutting mild steel you need to complete the tool, as well as the hardware, and you even get a machinable Morse taper arbor, as well as some nice plans and some build notes. If you're interested in building one of these yourself, I'll put a link in the description to where you can buy it from. The first component we're going to make is one of these clutch cones. We actually need two of these to complete the kit, one each side of the actuator. These are made from free cutting mild steel and are already at nominal diameter of 1 3/4. The first job is to face both ends of the stock, and then we need to bring the part to length. And the way I'm going to do that is using the DRO. So the procedure is take a measurement with the calipers, punch this into the DRO, and then it's simply a case of turning down the part until we hit our number, which in this case is 0.8125 of an inch, 13/16, or just over 20 millimeters. And you can see that we've hit our dimension pretty much spot on there. Now that we've got the part to length, I need to drill and bore the internal diameter. So we're starting off with the drill and then coming in with the small diameter boring bars. This incidentally was another Hemingway kit, that was also a good fun build. And we're periodically checking the diameter with the snap gauges and sneaking up to our final dimension of 1 inch. As we're making two of these parts, we need to make sure that those internal diameters are exactly the same. So in order to do that, I've turned up a bore gauge. Now the plans do say that it doesn't need to be exactly 1 inch, just as long as both parts are the same, but I think it's always fun to try and get as much precision as you can into a project, so I took the time to get this bang on 1 inch. And I've got a nice snug slip fit on that, so I'm quite pleased. For this next operation, we're going to turn the compound slide round to 30 degrees to cut the cone of this clutch cone, and it's important to leave the compound in the same position for the next few parts, because we need to cut matching tapers on those parts. Now the plan's call for the lip of that cone to be exactly 14 thousandths. Now I'm sure there's a way to work this out more accurately with trigonometry. I don't know how to do it. If you do, please let me know in the comments. I did it just with a set of calipers and I got close enough, I think. I think this part's going to be fine. The plans do say to finish this cone to a good surface finish. I've got some tool marks in it, but I went in with some 320, then some 400 grit emery paper, and then finally some Scotch-Brite, and cleaned it up quite nicely. I've got quite a decent surface finish in there, even though it doesn't look it does feel very smooth to the touch. So I made another one off camera, and that's our 2 clutch cones finished for the time being. We will come back and do some more work on them later. But for the time being, I'm just checking dimensions. They're both exactly the same width, and that bore gauge does fit in there quite nicely. I'm happy that they're both the same, and I'm quite pleased with the way that they've come out. The next part we're going to make is the larger of the 2 die holders. As you can see from the plans here, we've got a male taper which interfaces with the female taper of the clutch cones that we made earlier. There's a central section that the clutch cones ride on, and then there's a threaded portion at the end of the part that allows you to screw on the other die holder. We're going to start off by cleaning up the end of the stock, squaring it off, and just doing a light skim pass on the OD there. Now's the time to drill and bore the recess for the die itself. Now the plans call for a 1 5/16 recess here to hold an imperial die, but I've actually made one of these die holders before. I made that to spec, to plan, and that works brilliantly for my imperial dies, but doesn't work for my metric dies. So I'm going to make this one 38 millimeters, which is quite a bit larger, but it's going to fit my largest metric dies. So now that I've bored this to have the larger recess, I'm now a little bit worried that we haven't got enough meat on the outside of the part. Later in the process, we're going to have to drill and tap this for 3 M6 grub screws that will hold the die in place, and I'm just worried that we're not going to have enough thread engagement on those grub screws, but we'll have to just wait and see if it works out. So I've flipped the part round in the 4-jaw chuck, and I'm dialing it in now to make sure that it's running as concentrically as possible with the features we've just machined on the other side. And the first job on this end is just to clean up that saw cut end, square it off a little bit, and to put a centre in, because I want to bring some tailstock support, because we're going to do some turning now, and it is sticking out of the chuck rather a lot, so I just want to make sure it's well supported. The section we're turning down right now is going to comprise of 2 features. One is going to be a 1 inch in diameter section for the 2 clutch cones to ride on, and then the second part is going to be a threaded section. We're going to single point thread that, and that's going to screw into the die holder on the other end and hold the whole assembly together. And I brought the compound slide back into action here along with the boring bar, running the lathe in reverse, cutting on the back side there to cut the taper that's going to interface with the clutch cone. And before we go too much further, I want to just check the fit of those clutch cones on that newly created taper. And that is looking good. So we're going to clean it up now with a little bit of emery paper and Scotch-Brite, just to make sure that surface finish is as good as we can get. And then I'm going to bring the part to length. And I drill, bore and ream the part to 5/8 of an inch for the support bar that passes through the die stock holder. This attaches to the MT3 arbour, and it allows the die stock holder to slide up and down freely when it's being drawn onto a thread. The next feature I need to do is the screw thread. We're going to single point thread this in a minute. So I'm just turning that down to diameter and periodically checking the fit with the clutch cones that we've already machined. Just to make sure that they've got enough bearing surface to run on once that thread's been machined. I'm bluing the part up now to prepare for threading, and the plans call for a 7/8 by 26 TPI thread here, but I've decided to go for 22mm by 1. So yeah, just done a scratch pass there, and I'm just going to check that with the thread gauge to make sure that my my settings are all good, and then we can commence with cutting the thread. Now 22 by 1 is an oddball thread size. I doubt you could buy a die that size, but even if you could, it's going to be expensive. So hence the need for single point threading. And to make sure that I'm getting the fit correct, because we want quite a nice tight fit with the other part on this, I've machined up a little thread gauge there. Now annoyingly, I didn't retract the tool quick enough on one of the passes, and I ran the threading tool into the part. So you can see that the end of the body there is slightly chowdered up, so I'm going to have to come in and try and clean that up with the chamfer tool. I would like to try and master the threading away from the headstock technique as shown by Joe Pye on his channel. If you haven't seen that, go and check him out. I'll put a link in the description. That's a much safer way of threading. You know, you don't have any of the risk that you're going to run into the part. So that is a technique I would like to learn. I cleaned it up as best I could with the chamfer tool, but we've still got a few chowder marks on that end there. I didn't want to remove too much of that journal material because that's what the clutch cones ride on, and I didn't want to compromise that. This internal feature won't be seen once the tool's together anyway, so I don't think it's too important. So that's us done for now on this component. We will come back to it later on, but in the meantime we're going to make the die holder for the other end of the tool, and this again is made from 1.75" bar stock, and the machining operations for this first side are very similar to what we've done before. So I'm just going to turn that down, bore it, ream it, and then turn out the recess for the die holder. Now the plans call for an 1 7/16" recess on this side, but again, I'm going to be using metric dies with this tool, so I'm going to turn this down to 30mm. So I'm just cleaning the part up with some emery paper and some Scotch-Brite there, and then we can have a quick test fit, make sure everything fits, which it does, and then we can flip the part around in the chuck and start machining the other side. This part needs to be 1.275 inches long, which I have hit pretty much on the nose, which is good. And then the next operation is to bore out that central section so that we can do the internal threading. This internal thread needs to match with the external thread that we put on the last part. So in my case, it's 22mm by 1. And if you follow in the plans and you're doing it in imperial, then it's 7/8 by 26 TPI. And I'm just doing a quick fit check there with the other part to confirm that we've got a nice close fit. And much like the other part, we need to put a male cone on this side. So again, I'm running the lathe in reverse, and I'm using the boring bar to cut the cone. Now that we've done the lion's share of the machining on the main components of the die holder, what we're going to do is screw them all together nice and tight, put them onto a mandrel that I machined up, and we're going to do a skim pass across the outside of the tailstock die holder to clean up the outside diameter, bring it all to the same size and make it look nice. Now I'm actually using an aluminium insert here, but I find it works quite well on mild steel if you take light cuts. Finally, I'm going to come in with some emery paper, starting with 320, then moving up to 400, and then finding some Scotch-Brite, just to improve that surface finish, make it a little bit shinier, nicer to look at, and then we're going to chamfer those edges just to make the tool a little bit nicer to handle in the hand. Now we need to drill and tap 3 holes on each end to retain the actual dies. These are going to be done at 45-degree increments, hence the use of the spin indexer. Everything's clamped together on an arbour and then held by a 5C collet in the spin indexer, and I'm just edge finding here to find the centre of the part and also get a reference on the end. I'm supporting the end of the part here with a screw jack and a piece of copper just to make sure that it's as secure as possible. And yeah, I'm coming in with a spotting drill first, then the tap drill size for M6, then the tap, and finally I'm going to come in with a little chamfer tool. And now we need to index the part round by 45 degrees, so I'm loosening off the screw jack a little bit, going back to the indexing plate, moving it from 0 round to 45, and continuing with the next hole. And now the last one. Then I flip the part end for end and rinse and repeat. Deburring holes on the backside of an internal diameter like this has always been a challenge for me until I discovered this tool from Noga called a reversible countersink. It's got a movable blade that you can poke through the hole and flip out and deburr the backside of the hole, and it's just a real game changer. And I got this tip from Quinn over at Blondie Hacks. If you haven't checked her channel out, you definitely should do. I'll leave a link in the description. She's got some great videos. Time to move on to making the actuator and the arm now. I'm bringing it to length, and then I'm going to fly cut all the sides just to make sure that I get rid of some of that mill scale and improve the surface finish a little bit. And over to the bench vise to round those corners off with the file. This isn't critical, just aesthetic, but I did use some radius gauges to check them just to make sure they're all equal. And this was the final result. I need to machine the internal features now, and I've gone to the trouble of blowing it up and marking it out as an idiot check because I don't want to make any silly mistakes on the mill. And I'm using this 16mm roughing end mill to remove the bulk of the material, and then I'm following it up with a smaller diameter. I think it was an 8mm 4-flute carbide end mill to finish those that internal pocket and to get a tighter radius on those corners. I need to remove that thinner central portion there to form the 2 small arms of the actuator, and to do that I'm going to go back to the bench vise and break out the hacksaw to remove the bulk of the material, and then I shall finish it off in the mill with a carbide end mill. I've flipped the part around in the vise and I'm finding the centre now so that I can drill a through hole to accommodate the handle. The plan's called for a 1/4 inch through hole here, but I'm doing it 6mm just because I feel rebellious and because I don't have any 1/4 inch drills. So that's the actuator finished, and we just need to make the arm now, which is a really simple turning job. I turn it down to 6mm on one end, or 1/4 inch, and thread the other end for M6. And assembly is just a question of screwing the knob on one end and Loctiting the other end of the arm into the actuator body. The final bit of machining we need to do on these clutch cones is to mill a slot into the back of them in order to accept the actuator arms. So I'm just centering it up here on with the edge finder, and I'm touching off on the surface of the part to get an accurate depth cut, and then I'm just going to go ahead and mill the slot. So I did the same with the other one off camera, and that's our clutch cones finished. The last part I made off camera because it's just a simple turning job. It's an MT3 stub arbor like this one that's got a soft machinable head on it. And you just turn down a section of it there and you put a thread on. I used M8, but you can use 3/8 BSF. And then you make the support bar, which is just simply bored down the middle and threaded on the end and screwed together and Loctited. So how does this clutch mechanism actually work? So we've got the 5 main components. We've got the die holders at each end. We've got the 2 clutch cones and the actuator arm. Now these die holders have a male taper on, and that interfaces with the female taper on the clutch cones, and the clutch cones are free to spin on that journal in the middle there. So we fitted one clutch cone, the actuator arm, then the other clutch cone goes on, and finally the last die holder screws the whole mechanism together. So we lock the whole thing down tight, and then what we need to do is just to back off that screw thread a touch so that those clutch cones are free to spin. Now when we operate the actuator arm, the fingers of the arm twist and force the clutch cones into the male tapers of the die holders, and the whole thing locks together, and it's really that simple. Now to ensure that the mechanism doesn't unscrew itself during use, we're going to use some Loctite 648 on the internal threads of that die holder there. Now the trick here is to apply the Loctite, get everything assembled, then lock it all together, and then just back off that screw thread just a little bit so that the clutch cones can spin freely during use but still lock up when the actuator arm is used. Off camera I made this auxiliary die holder accessory. Now in my case we've got a 20mm die recess and a 25mm die recess, but on the plans it calls for 13/16 and 5/8. We've got the grub screw holes drilled much the same way as I did the last ones, and I've also created these little recesses for the set screws of the main die holder to locate in. And we use it in conjunction with the main tool. The ODs on the accessory have been machined to be exact fits for the die holders on each end. So now it's time to give it a test drive, and I've selected the biggest die I can find, which is an M16 by 1.5, which is just over 5/8 of an inch, so quite a big die. I'm only using brass here, but it's not struggling at all, as you can see. I mean, it's straight in, and then the clutch kicks in brilliantly, and then we put the lathe in reverse, clutch kicks in again, and we end up with a beautiful thread, which I'm really pleased with. So the question we've all been waiting for, is this the best tailstock die holder available for the home shop machinist? And in my opinion, the answer is a resounding yes, and that's for 3 reasons. Reason number 1 is the design, and this was designed by a guy called J.C. Payne. I have no idea who he is, but he's done a cracking job with this clutch mechanism. It's just so functional and so easy to use. You know, and it's really changed the way that I cut threads on the lathe. I mean, I never used to cut threads under power, but now I feel confident I can because of this clutch mechanism. You know, and the fact that it kicks in when it hits that shoulder. You know, it's just a vast improvement over anything else I've used, in my opinion. Reason number 2 is cost. Now Hemingway Kit supplies this, I'll leave a link in the description, and it's really inexpensive. It's kind of on a par with what you'd pay for a new import tailstock die holder, and in my opinion this is far superior. And reason number 3 is that you can build this yourself in your home workshop. It's a really fun little project. It's incredibly satisfying to have a useful tool like this that you've made yourself, and you know, you don't need really capable machine tools to make it. You could make this on a mini lathe. You don't even need a mill really. I mean, you know, those 2 slots on the clutch cones for the actuator arm, you could do those on a milling slide on the lathe, or you could even I dare say file them. I mean, if you had to, and the handle. I mean, you know, you could do that with drills, fret saws, and hand files. As always, I love hearing from you guys. So if you know of any superior designs to this tailstock die holder, I would be genuinely interested to hear. So please do let me know in the comments. I've got plenty more tool making videos coming up, as well as other types of content. So if you've enjoyed this, then please do hit that subscribe button. It really does help me out with the channel. And you know, feel free to comment and let me know if there's anything else you'd like to see me make. I'm always happy to take suggestions. So thank you very much for watching. It's really appreciated, and I hope to see you next time.